determine the answer on this one, but I can find another problem in the book that's similar for
Yeah.
you two.
So whatever, if you want me to redo that, I can redo that, or
Yeah, I just had, can you read the outline?
yes.
It says that s prime of x is 0.24x squared.
0.24.
X squared.
Very good.
Plus 4x.
Yes.
Plus 10.
Yes.
Where x is the price per unit in dollars. And find the supply function if it is known that the seller will sell 121 units of the product when the price is $5 per unit.
So S of $5 is 5.
They want to sell 121 units, and it's when the price is $5 per unit.
That's what it means. When the price is $5, S of 5 is 121. Good. So in order to find the function, I have to basically integrate indefinitely 0.24x squared plus 4x plus 10 dx. I don't have to write it like this, but that's what I'm doing. So this will be 0.24x cubed over 3 plus 4x squared over 2 plus 10x plus a constant c. Is that clear so far? So the information we have that x is 5 and s of 5 is 121, it will enable us to find c. I would like to simplify before we continue. So this will be 24 divided by 3 is 8. So 0.08 x cubed plus 2x squared plus 10x plus c. Is this okay?
Yes, because you're basically just dividing.
Yeah, I'm just simplifying so I don't have fractions in there. And now I will plug in 5.
5 for x.
Right. So because I know this is my function, right? So S of 5 equals 121. So 0.08 times 5 cubed plus 2 times 25 plus 10 times 5 plus c is 121. And from here I get c. So we have 0.08 multiplied by 125 plus 50 plus another 50. And this will be subtracted from 121. So 121 minus that. And I got 11. So then c equals 11. So the true function is 0.08 x cubed plus 2x squared plus 10x plus 11. Is that okay?
Yes.
What was the question you think, or
It says
the misunderstanding, or
that it is known when the seller will sell 120 units of the product. So basically, we're just finding c then. That's it.
you're finding the function?
Finding the function in terms of c though.
No, you're finding the function. This is right now a family of functions, but the information you are given enables you to find the unique function that is this.
Okay, perfect. And so yeah, no, that was it.
It's just this is the most general antiderivative, but we actually want to determine one specific one. And the information was given to us to help us determine c. This information was given for c, but this is the derivative that I had to integrate to find the function. So the question is about the function.
And really, with the function though, at the beginning when we integrate it, it's because you have 0 to 121 products or units you're selling, correct? That function suits 0 to 121 units.
Not necessarily.
Oh, it could suit more than that.
Anything.
Okay.
Anything. This is one piece of information given for us to find c.
Okay.
We are not integrating definitely. It's an indefinite integral because we are asked to find the function.
Gotcha.
Oh, this is indefinite?
Definite is where they have the endpoints.
Right.
That's why
Limits of integration.
the limits correct.
Correct.
I wanted to make sure because it said 121 units that I wasn't confusing it that it was from 0 to only 121. So I just
No,
wanted to make
no. We are asked to find the function, and the piece of information we're given is to enable us find C.
Gotcha. No, I understand it now. Okay.
If you remember when we talked about the antiderivatives, we said we could be given S prime and we will find S, right, in this case, F prime, and we find F of X. But if we are given the function, we will be finding uppercase F of X. So this is just an important piece of notation difference. So here we were given S prime, we were asked to find the function.
Gotcha.
Good, next one.
Did you think of anything for
Yeah,
test
there was-
three?
Oh, just from test?
No, no, just in questions in general, but I was just going over things for test three.
Okay, yeah, there was. Maybe we might pass this Spanish.
Yay!
What happened?
She passed her
No,
Spanish.
I might, so I think I might, I'm confident.
Oh, okay, well, she thinks so. Confidence good. It's bueno.
Anything else?
Yeah, there was one, I just can't, oh, right here, no, it was page 423, number 90.
Number 90 on page 423?
Yeah.
In the book, that
Yeah.
means. Okay, very good.
You want me to read it?
Oh, I have the book, I just don't have the previous forms. For some reason, I cleaned out my backpack, and so page 423. 423, problem 90. Okay, the divorce rate. The divorce rate in the United States is approximately D of T, 3.95 e to negative 0.0121 t. Okay, D of T is the number of divorces per 1,000 people. So this number is number per 1,000 people. Okay, yes?
This lead is just 0.12.
0 point.
Oh, there's not a one at the end. Okay, okay. Sorry.
It's okay, just in case.
Sorry. T years after 2000, so T equals 0 represents the year 2000. Perfect. Find the total number of divorces per 1,000 people in the United States from 2000 to 2008. Note that this is given by, so we are really asked to find the integral from 0 to 8, from 3.95 e to negative 0.012 t dt. And then part B, find the total number of divorces in the United States between 2008 and 2016. Okay. I remember doing this problem. Let's do it again because it's an important situation. So first of all, the constant goes out. And if you remember, we're going to use a substitution for this. We're going to say let y be negative 0.012 t. Then dy will be negative 0.012 dt. So I have dy being a product of two pieces. One piece is here, but I don't have this piece. That's not a problem. I can multiply by negative 0.012 and divide by negative 0.012. Now I have dy composed by these two pieces. This will be my dy. This number goes in front at the top. It's a numerator, not the denominator. And this becomes e to y. So we continue. So this will be negative 1 over 0.012 with 3.95 in front. Do not copy the limits of integration. And this will be e to y dy. So let's see if this is clear. Is this clear so far?
Yeah.
So this will be e to y because I denoted by y this. This is already there because it's my dy, so this piece. This is outside of the top. And now the limits of integration. When, I see two, sorry. So, thank you. So when t is 0, how much is y?
0.
Excellent. When t is 8, how much is y? Well, it's 8 multiplied by 0.012, and we can do this, but it's negative 0.096. Very good. Good. So now finally, I have negative, I don't know if, I just want to see if this is divisible to make it nicer, but it doesn't have to be. No, it isn't. So 3.95 divided by 0.012 is, yeah, you can leave it as is. So negative 3.95 over 0.012. What function prime is e to y?
E to y.
Of course.
E to y.
E to y. So then from 0 to negative 0.096. What do we do next? We keep the number outside, and we plug in the upper limit, e to negative 0.096 minus, when I plug in 0. When I plug in 0, what do I get?
1.
That's it. I'm going to approximate the whole thing at once, not punching in different steps and so on and so forth. So negative 3.95. Let me show you how to do this because this is important, and just to make sure you're doing it correctly. Okay, so negative in front, 3.95, open the parenthesis, e raised to, in parentheses, negative 0.096, close the parenthesis, come down, and minus 1, close the parenthesis, and now divide at the very end point by 0.012. Be very careful how you put it in because you will get different answers. So the answer is approximately 30.13. So what does this mean? 30 divorces per 1,000 people. In part B, find the total number of divorces in the U.S. between 2008 and 2016. So this time we have to determine the integral from 8 to 16, from 3.95 e to negative 0.012 t dt. So what changes? Just the limits of integration, nothing else. So I can go back and copy this piece, but with different limits of integration. So this will be negative 3.95 over 0.012 e to y, but careful now. When x is 8, I already have the answer. It's the same thing. It's the negative 0.096. But now when the upper limit is 16, I have to determine, so 0.012 times 16, and this is negative 0.192. Everything else is the same. So now I plug in the upper limit, negative 3.95 over 0.012, and I have e to negative 0.192 minus e to negative 0.096. Let's put everything in the graphing calculator. Okay, ready? I'm just going to copy everything I have with second and entry. So the first one, I have to change the power. So the power is negative 0.1 9, 2. Now the second one changes from 1. I'm going to delete the 1 and insert e raised 2 in parentheses, negative 0.096 and close the parenthesis. And when I press enter, I will get roughly 27 divorces per 1,000 people. Divorces here and also here. So I shouldn't even say 0.13 because we can't have 0.13. So about 30 per 1,000 people, and here about 27 per 1,000 people. Very good question. Is this okay?
Yeah, I guess maybe when I was copying it from the video, I did something out of order.
No, I don't think you did. So I think when I did this, I rushed to the second part, and I don't know if I put the limits of integration correctly.
Okay,
because we talked about that, and I said, "Oops, I'm rushing, and I shouldn't be rushing." Yep, I remember that.
Okay, then I'll refer back to that one.
Yeah, so my apologies for that. Because I was supposed to change both limits of integration. I think by mistake I only changed one. So
Okay.
yeah, my error.
Can we do a few more where we just evaluate the integrals?
Yes.
I'm gonna find where they're.
Just any integrals or?
Yeah, mostly I have like an issue like from our test packet very similar to number C.
Yes, can you give me that?
We solved it, but it was x to the third over 2 minus x to the fourth parentheses to the seventh power, just the bottom, and then dx.
What packet is that?
This is for test 3.
So Emily, you take the test in the testing center?
I'm gonna take it in the testing center probably on Saturday.
Okay.
My schedule's all messed up now.
So I'll be here from 10:30 on Saturday, but I need to know because I already sent the test out. So I need more copies. So I'll be in this room for 10:30.
I will be here at 10:30.
Okay.
Sorry.
I'll be here at 10:30.
I will be here at 10:30.
You testing center? I don't remember.
I guess I can come here. Yeah, I can come here.
Okay, 10:30 then. Good. So is this a problem?
Mhm.
Okay. So remember substitution rule. We're going to say the same thing what we just did a few minutes ago. 2 minus x to the fourth. Can we get dy? Can anyone give us dy?
Negative
Yes?
4x.
Yes.
Yeah.
Exactly. So now all I need here is I have this piece, but I don't have this piece. But that is never a problem. I multiply the top by -4 and I multiply the bottom by -4, which means I multiplied by 1, which means I didn't change anything. So then outside is a -1/4. And now can anyone dictate the integral inside?
dy over y to the 7th.
Excellent. That's it. So then this becomes a -1/4. The integral from y to -7 dy, because it's easier to integrate y to -7. So thus we have -1/4 y to -6 over -6 plus a constant c. This is good, but it's not good enough. It's an indefinite integral. I have to go back to the variable. So Negative, yes?
I get all the way up to the very last part. Why did we do the so we bring the negative 1/4 over. Why did we do y to the negative 6 over negative
That's the rule. We increase the power by 1 and we divide by the same number.
Okay,
That's the rule.
and a derivative. Okay.
So this is 1 over 24. I will write 1 at the top. I'll erase that. And then y is 2 minus x to the 4th to the 6th plus a constant c. That's the rule. When we integrate x squared, we get x cubed over 3. The same thing here. When we integrate y to negative 7, we add 1 to the power and we divide by the result. Right?
Yeah.
So it's the same thing with x cubed dx, which is x to the 4th over 4 plus a constant c. Now I have power negative 7. Negative 7 plus 1 is negative 6 over negative 6. It's the same rule. Better? Perfect. Good. Next problem.
Can we do one with an absolute value?
Yes. Any.
There's one that
Yes.
we already did.
Yes.
Page 412, number 7.
Number 7 on 412. Let's do that. 412. 412, number 7. Number 7. Yes, the integral from 0 to 4 from the absolute value of x minus 3 dx. Excellent. So first I have to identify what this means. And we know the absolute value can have can wear two different hats. It will be x minus 3 if x minus 3 is greater than or equal to 0. But it will be the opposite of x minus 3 if x minus 3 is less than 0. This is the definition of the absolute value. So now I have to write x minus 3, and this is x greater than or equal to 3. I'm solving this to get this. And then negative x plus 3 for x less than 3. So therefore, I know that this integral must be a sum of two integrals now. One of them will, so there is a break at 3. So an integral from 0 to 3 and an integral from 3 to 4. Why? Because between 0 and 3, I have this function. And between 3 and 4, I have this function. It's not just one function. So let me show you a picture of this. It's a very good pic. We didn't finish. I'm coming back to finish it up, but I just want to show you a picture. The absolute value of x minus 3, if you remember, this is the absolute value of x. But the absolute value of x minus 3 is this. This is the absolute value of x minus 3. We are trying to integrate between 0 and 4. But 4 is here. So see, between 0 and 3, we have one function. And between 3 and 4, we have a different function. So that's why we determine this area from 0 to 3, from negative x plus 3 dx. And we determine this area from 3 to 4 from x minus 3 dx.
Okay, that's what I was confused about, where we got this number.
So now, in order to finalize this, we will have negative x squared over 2 plus 3x from 0 to 3, and plus x squared over 2 minus 3x from 3 to 4. Is this better?
Yeah.
So then I will plug in 3. So negative 9 halves plus 9. There is no need to plug in 0 because everything will be 0 when I plug in 0. So now plus 16 over 2, which is 8, and minus 12, minus, careful, put parentheses so you don't forget to distribute, 9 halves minus 9. So then, this is negative 9 halves and plus 17 minus 12.
5.
Right. And then minus 9 halves, and then plus 9. These two will be negative 18 over 2, which is negative 9. So the answer is 5. Is this better? Perfect. Very good example. Next question.
Can we do a few more definite integrals?
Yes, this was a definite. This was definite.
Oh yes, because we had our limits.
Yes.
Can we do one like number 57 on page 422?
Just for you. Just kidding. So you said 422, 57? 57 it is. Okay, 57. I see it. The integral from 0 to 2. Make sure I copy the right one. You know me already. 1 plus x to the third. Everything to the fifth. Did I copy the correct one? I didn't manage to copy from half from one problem and half from the other. I do that a lot. Okay, so again, this is the problem right here. So I'm going to try and say y equals 1 plus x cubed. But this is a good substitution only if it works, right? If I have dy in the problem. If I can't find dy or I can't make up dy and it's not in the problem, then it's not the right way.
Okay, so 3x squared dx.
Exactly.
So,
Do I have this in the problem?
Yes, you do.
Yeah, it's right here.
so if you chose the numerator on accident or whatever, you would know because once you find
Exactly. But also remember,
Yeah,
so
I was gonna ask that.
here's the thinking process. Am I really it's not scientific, but it's easier to understand, I think. Am I bothered by 3x squared? No. I can separate it, I can do things with it, but I'm bothered by two terms to a great power in the denominator. Because I don't know how to handle that. So if I denote what it's in parentheses and I somehow have the dy in the problem, I'm on the right track. Because that becomes just one quantity raised to some power. So that's the idea behind this is the thinking process. So what can I do to make this look nicer and easier, right? So now this becomes
dy over y to the fifth.
exactly. Do you prefer this or you just prefer dy over y to the fifth? In other words, y to negative 5 dy.
That one.
Right. However, you have to stop for a moment. Do not copy the limits of integration. You understand that these 0 and 2 are limits for x, not for y. So when you create a function and you move on to y, you cannot copy the limits of integration used for x. So when x is 0, how much is y?
1.
When x is 2, how much is y?
7. 9.
Right?
Yeah, it's 2 to the third.
Yes, 8 plus 1. Good. So then I have to increase the power and divide by the same number. Y to negative 4 over negative 4 from 1 to 9. Leave the negative 1 over 4 outside. 1 over 9 to the 4th minus 1. And you don't have to do anything else. You don't have to distribute, you don't have to try to simplify. This is good enough for me. Now my math lab may want blah, 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 blah. This is what I need. Because anyone can punch this in the calculator and get a number or, find the least common denominator and multiply. Good. Good problem. Next question.
Do we have anything similar to like number 8 on our test 3 packet, which was the y prime equals 5y to -2, and it tells you when y and when x is a number? I'm sorry. Just something similar to this that we could work on?
Oh, differential equations, yes. That's what I thought. Differential equations are at the end of chapter 4, I believe. Not the last section.
Is it 5.7?
Could be. Yeah, because I couldn't find it in chapter 4. Yes, I'm sure. Yes. Thank you. Thank you. I'm looking maybe some nicer problems at the end of the chapter.
So like 509 maybe?
Which one?
Like on page 509, are we looking at like maybe 1 through 14 there? There's something we could maybe see.
So 11 through 14, they're giving you the solution. They're asking you to show that is a solution.
Okay, which is, we did do one of those in the test 3 package,
Right.
which was the one we did on, for number, oh shoot.
Yeah. So what you showed me is on basically on page 510.
Okay,
Let's say 39.
okay,
Does this packet cover all the sections?
Yes. The final exam?
The test 3.
Yes.
I'm gonna pick from test 3, because we're taking it Saturday for today, and then I figured Tuesday we can all go to stuff for the final.
We're here on Tuesday?
No.
Oh, no, we're not here.
Today's the last day.
Oh, okay. And then we just come on the 16th for the final. then?
Yes.
Okay, so
Is it at 7?
Oh, I'll be here from 1 o'clock.
Okay, so come.
So we could come in
okay,
Anytime.
so anytime.
I'll be here from 1 till 8.
Okay, okay,
Come in anytime. Now, I'm giving finals, so I'm not going to be able to talk.
right,
But if you say, if nobody's here at 1 o'clock, then you have questions, then we'll work on whatever you want.
okay.
Very good.
Do we have the option? If not, totally fine. Like for example, I finished my A&P exam at 4:45. If you didn't have a class going on, would we be able to start our exam early, or would you prefer us to wait?
No. I'm giving exams. I'm not doing anything. From 1 to 8, everybody's coming in, takes the exam, sits down, and I read the paper. I don't read papers anymore. I read my books.
Okay.
The idea was to read a paper. It was a friend of mine who would make holes in the paper and just watch people and see if they were cheating.
That's the whole question.
So no, I'm not reading books.
It's not a bad idea. It's kind of funny.
Okay.
This isn't so bad.
So
Just
anytime.
remember we cross multiply.
First of all, we cross multiply because this is y dy equals 2x dx because we want to separate the variables. We want everything with y on one side and we want everything with x on the other. And now I will integrate. The left-hand side is y squared over 2. The right-hand side is 2x squared over 2 plus a constant c. Is this okay?
This part I can get.
Good. So then, these go away, right? 1 and 1. So I have y squared equals x squared plus c, everything multiplied by 2. Agreed?
Yeah, so we just move the 2 over.
We multiply. It's divided.
Yeah, and then we multiply the other.
Both sides by 2. We multiply both sides by 2. So then y will be plus or minus the square root of 2x squared plus 2c, which we like to denote again by a constant. We don't really care that it's multiplied by 2. But it's okay if you just keep it as 2c. That's fine.
So is that our end result? That's our answer?
Yep.
Okay.
We're asked to find y, the function that satisfies the differential equation.
Can we do one where we're given y prime and we need to solve for, they're gonna give us what y equals and what x equals?
That condition is given just to determine c.
Right, just to
Yes.
determine.
Let's look at 46. You just have to plug it in.
Okay.
Good. 46 y prime equals 7y to negative 2. And we are told that x is 1 and y is 3. As a point, of course, 1, 3. So first I go to dy, which is, to y prime, which is dy over dx, equals 7 divided by y squared. And we proceed accordingly, exactly what we did a minute ago. We integrate like we just did. We will have y cubed over 3 equals 7x plus a constant c. Of course, we'll multiply everything, yes. You can write 21x plus a constant c. When I multiply 3 by c, I still get a constant. And then I will have to take the cube root. So I think it's better before we take the cube root. So let's do that. Sorry, I forgot that the condition was given. So when x is 1, y is 3. So 27, 3 cubed, 27 divided by 3 equals 7 times 1, which is 7, plus c. So this is 9, this is 7, so therefore c must equal 2. So I don't have to write this. I can plug in the values later, but I think it's better if we stop and do this now. So then I know that y cubed equals 3, 7x plus 2. When I distribute, I get y cubed equals 21x plus 6. And now I will take the cube root. 21x plus 6. So now this is a unique function, because the condition was given to find c. We can find it now or we can find it later, but I prefer finding it before you take the cube root. It's easier.
Sorry, how did
So this was not a mistake, but it's easier if we determine c. Yes?
how did you get c equals 2?
Because I'm told y is 3 when x is 1.
Okay.
So I plugged in 1 and I plugged in 3.
Okay.
Better?
So when you found your equation, don't you have to do plus 2 now? Because c is 2? Yes, I see what you did. Okay.
And then I distribute, and then I take the cube root. Is that okay?
Yes. can we do one where we find the relative max or min of
Yes.
a function of x and y?
Yes, you mean the d-test.
Yes.
Yes. Do you have one?
No, I have to look it up in the book. We did do one on our test, but I just want us to do another one.
Sure. So this is page 547. This is max min,
Okay.
section 6.3.
Can we do
I can choose a function if you'd like.
okay, that would be good.
Let's say problem 3 on page 547. Problem 3, f of xy equals 2xy minus x cubed minus y squared. Make sure I copied it correctly. Is it? Okay, I'm going to change. Good. So we're asked to determine whether this function has a relative, not absolute, relative max or min. Good. So step 1, I have to find fx and I have to find fy. In step 2, I will set fx equal to 0 and fy equal to 0. And I will create a system to find a point or points. I don't know. So first let's find fx. Everything is considered constant except x. So when I differentiate this, what do I get? Excellent. When I differentiate this, what do I get?
0.
Negative, minus 3x.
Very good.
And then you get 0.
And that's 0.
Okay, y is in terms of x.
Good. So now we want to differentiate in terms of y. The first one.
2x.
Perfect. The second one.
0.
Excellent. Minus?
2y.
Excellent. So now this is my system. 2y minus 3x squared equals 0. 2x minus 2y equals 0. They're critical numbers, right? That's what we're doing. We differentiate and set them equal to 0. Perfect. So, oops. Good. So here I will definitely divide both sides by 2, and then I get x equals y. I will replace x by y or y by x. So I prefer replacing this by x. So I have 2x minus 3x squared equals 0. Are we okay so far?
Why did you do that?
Oh, I need to solve the system.
Okay, so you can't have both x and y. And then
Yeah, I don't know how to solve with two variables in the same. Yep. So now I will rearrange this as negative 3x squared plus 2x equals 0. Multiply by negative 1 because I don't like a negative leading coefficient. And pull out an x. And have 2 options for x. And obviously I will have 2 options for y. X is 0, then y is 0. X is 2/3, then y is 2/3. Because x and y are the same. So in this particular situation, we're looking at 2 different points. Can anyone dictate the first?
0, 0.
Excellent. And this, perfect. So then we have to conduct the d-test, right? In 2 different situations for 2 different points. Okay, now in step 3, we have to find fxx, fyy, and fxy. We need them for the d-test. Ready? So we go back to fx. We need to differentiate this one more time with respect to x only.
So negative 6.
Excellent. We go back here. We have to differentiate this with respect to y only.
Negative 2.
Excellent. And now we want to differentiate this with respect to y only.
2.
That's it. In step 4, we conduct a D test. D is fxx of 0, 0 times fyy of 0, 0 minus fxy of 0, 0 squared. How much is fxx of 0? 0. How much is fyy of 0?
-2.
Right. How much is fxy at 0, 0?
2.
Minus 4.
Oh, okay.
So this is 0, and we get -4. What do we conclude? What happens at 0, 0? Saddle point.
It's less than 0.
Because it's less than 0. D is less than 0. Any questions?
So now we have to go back
And
do
yes,
x of 2/3, 2/3, 2/3.
exactly.
Okay, because we ended up with 2 points, so you have to do the D test for both points.
Yes?
Okay.
So obviously this is not a relative max or a relative min. So let's redo all the 4 steps for 2/3, 2/3. Ready? So basically just the D test. That's all we need to do. I'm sorry. We already did all of that. So for D, fxx, let me write it. fxx at 2/3, 2/3 times fyy at 2/3, 2/3 minus fxy at 2/3, 2/3 and everything squared. Let's see what we get. So fxx when x is 2/3,
-4.
so it would be -4 indeed, multiplied by fyy does not change no matter what, it's still -2, and the same thing with fxy doesn't change no matter what, so it's 4. So the answer is 8 minus 4, which is 4, a number greater than 0, which is good. But now I have to look at fxx. How much is fxx? fxx at 2/3, 2/3 is a number less than 0. What does this mean? When D is positive and fxx is less than 0.
Means it's a max or min.
Which one?
When it's less than 0, it's a max.
Correct. So 2/3, 2/3 is a relative max. Can you find it? Yes. F of 2/3, 2/3 will be the relative max. And where is the problem? Okay, so this is 2 times 2/3 times 2/3 minus 2/3 to the third and minus 2/3 squared. This will give us the relative max. So this is 8/9 minus 8/27 minus 4/9. 8/9 minus 4/9 is 4/9 minus 8/27. So that is that is 4 times 27. Oh no, actually it's 4 times 3. You can tell that this semester has gotten to me too, not just to you. No excuse. So the least common denominator is 27, so I have to multiply this by 3. So 4 times 3 and minus 8. So this is 4/27. And that is the relative max.
I'm confused about fxx. How did you know? Can you go back up?
Because I wrote it here. This is the fxx.
Where did you get -4?
You have to plug it in. I have -6x and I plugged in 2/3.
Okay.
That's why I wrote it so I don't have to go back to it.